My name is Ron Duff, and I am a technical instructor with Cognex, Georgia, outside Atlanta, which is where I'm speaking to you today. Today we're going to talk about location tools. This is, as you can see on your screen, the third session in our full Insight class. The Insight we have now point 1, which includes EasyBuilder. Have either of you seen EasyBuilder yet?
Yeah, we've downloaded it, but I haven't really tried to use it yet. As I said, it's just modifying existing programs that weren't EasyBuilder configured.
Okay. Here, let's go through the slides, and I'll give you a little bit of a demo. I've got it running here on my computer. First of all, location tools. If you're new to Vision, a location tool also is called a fixture. It's basically an anchor point. If you can imagine your parts coming down the line, not every part is going to be in exactly the same spot in reference to the camera. Set a location or a fixture, and as the part moves in the X, Y, or an angle, all the other tools adapt to it. That's the definition of a location tool. I'm going to give you a little demo here in a little bit and show you exactly how you would use a location tool, and of course using it in a sample image. Location tool, as I said, is used to determine the X, Y, angle, and also scale. Your part or whatever you're looking at may change slightly in scale, and we can adapt for that. In this slide you can see we're looking down at a bracket. Brackets down in our field of view, and you can see that the X, Y, the angle in the middle picture, and to the right the scale of the bracket has changed. So the fixture or the location tool is what's taking care of that for you. Again, the locating is also called fixturing, or the point that you determine to be your location is called a fixture. And there's two different types. An edge tool, examples on the left, you can see that we've drawn two boxes. The one on the left says found, and the one on the right says not found. You'll know that it's found an edge it'll put a green line on it. If it doesn't put a green line on the edge, then it has not found it. The problem in this particular example, which is common with people who are new to Insight, draw the box, the arrow has to be across the edge. You can see on the example on the left that the arrow is pointing perpendicular to the edge and it has found it. If you set the arrow parallel to the edge, it's not going to see it. If you're standing next to a cliff looking into it and you take a step, you're going to find that edge. But if you were standing perpendicular to it and took a step, you wouldn't see the edge. Common mistake though. The example furthest on the right is an example of a pattern tool. Identified an X as the pattern we're going to use. You can see that it had taken inside the search box, the X has a green outline to it with a crosshair. That's actually telling you that it has seen and found that, and you have used that for the fixture. Here's a couple of examples. Fixtures. On the top you see the location tool, and you can see that it has contains again an X, a Y angle, and scale information. Edge fixturing is only X and Y. You can also use two edges, which is what the photo on the top right is doing. We've located two edges on the air fresheners there, and that is going to be our locator or a fixture. We also use circles or blobs. Blobs. Are you both of you familiar with blobs?
Yep.
Yeah, no, I'm not.
Okay, good. First of all, it's not just a garbage word. It stands for binary large object. What that means is basically any two pixels blob. If they're touching each other, they're a blob. So a blob can be of any shape. It's not necessarily a circle, a square, or anything else. So if you have any two pixels of the same density touching one another, that's a blob. See, almost everything is a blob. It's a nice way of saying a shape.
Okay.
Here are some sample applications that we've used this for. You can see the bracket we were looking at before, the top right. You might be manufacturing the bracket. You want to make sure that all of the holes are there. So first of all, you want to find something in that bracket that you want to fixture to it. So again, so as that bracket's coming down off the assembly line, if it should move in the field of view, left, right, angle, we'll go out and find it. Look at the right spot to see the holes. Or below that, you can see that these are all live images. They're all real images from real customers. Below that, you can see some beverage bottle. They're fixturing to the top of the bottle so they know where to go and look, make sure that the beverage is inside the bottle. Customers tend to be upset if their bottle's empty. Other examples there.
Okay.
One of the algorithms that we use here at Cognex called a PatMax, Pattern Max. PatMax, as you can see in this drawing, not based on the pixels. Pixels, if you're new to machine vision, is a picture element. If you're looking at this picture, you can see sort of it's made up of a bunch of squares. Each of those squares is a pixel. So in this case, PatMax isn't looking at the pixels. It's actually just looking at the outline of the shape, is what we're trying to show you there in the green outline. Basically, that is a contour. So as it says in the third paragraph here, a feature is a contour. Now, what is great about that PatMax, if you were to interrupt that contour, piece of paper, a piece of dirt, something interrupted, PatMax is smart enough to figure that out. It also, by looking at the contour, not the pixels, is much quicker than if it were actually having to go dive down and dig into the pixels. So PatMax is a very powerful tool. Here's an example, PatMax. In the picture on the left, compare that to the picture in the middle, you can see that there are some differences. Top left is not colored, the bottom right's not colored. PatMax is smart enough to say, well, the outline, the shape's the same. Go ahead and fixture to it. Again, the crosshair you see there is fixture. All the way on the right, see that it's changed again from the original. But again, PatMax was smart enough to figure out that that is the same basic shape, and they go ahead and use it. What we're looking at there, as you can probably tell from the crinkle, is candy wrapper. So on the right, you can see all of the metallic noise in the background. PatMax doesn't care because it's not looking at the pixels. It's just looking at the broad outline. So there are 5 location tools: PatMax, Patterns, Edge, Blob, and Circle. PatMax and Patterns are just about the same. PatMax is a more powerful tool, not as accurate as Patterns. As you might expect from that, Patterns is a little bit faster. Have a nice crisp edge, and you don't anticipate having problems, or you're testing, you don't see that you're having problems. You might just go with Patterns because it's a little bit quicker than PatMax. We'll do the trick for you. Then you have PatMax Pattern, much powerful tool. A little bit slower, but much more powerful. One example of that is if your lighting is going to change. In a lot of shops, the lighting, day and night, for example, the lighting changes throughout the day. PatMax basically will ignore that. So on the bottom example here, you can see we've gone out and we've set the Cognex logo as the fixture, as the location tool, outlined it for us, the crosshair over it and said, yep, I found it. Here it is. And I'll give you a demo. It's a little bit hard to see in this screenshot, but I'll show you a little bit better, more detail here shortly. When you add a PatMax pattern tool, If you're new to EasyBuilder, this is EasyBuilder that you're looking at here. The spreadsheet, if you're familiar with Insight, still exists in the background. We basically, our other product lines that we at Cognex have is Checker, and we also have Intellect, which came from DVT. So if you're familiar with either one of those, this looks a lot like Checker or Intellect, which was a image-centric interface. Traditionally, Insight was just a spreadsheet with the image kind of buried behind the spreadsheet. So we basically took the best of both worlds and brought them together here. So along the left side is its application steps, and it shows you, here's how you go through setting up a job. Get connected, basically connect to your camera. 2, set up the image. Basically set up the camera, make sure that the part is in the field of view. Locate parts, the 3rd step. That's what we're looking at now, basically setting the fixture. And you can look down the list there. After that, you would do your inspection. You would set your inputs, your outputs, your communication. Once you're done with all that, you run the job and off you go. One of the demos we do in class is have our students set up a job in EasyBuilder and then set up the same job spreadsheet. We've had people go through EasyBuilder and set up a real job in less than 2 minutes. Same job in spreadsheet would probably take you at least 15, and that's if you're very skilled. A big difference. I had a student recently said it was too easy builder. All the fun out of it. Again, here is a location. Again, if you're new to Insight, if you look on the bottom there, the green box on the outside is the search region. What looks to be sort of pinkish in this picture is the model region. So when you're ready to set your fixture, you set the model region around what you want to make the model, what you want to make the anchor point. Then the search region is where in the field of view it's going to look for that particular model. So we want to make sure that the model region is always smaller than the search region. Again, here you can see we've set a little bit easier to see there. You can see that in the model that the edges are all defined with green, and you have the crosshair that says, yes, I found it. In the tool itself, in EasyBuilder, you can see there's 2 different tabs there. This is the General tab, where you can take this tool. By default, it just comes up Pattern 1, but you could change that name, Cognex logo, whatever, and save it. Tool Fixture. Tool Fixture on other tools is going to be what we're setting now. So you don't normally fixture a fixture to a fixture. Let me try that again. Fixture to a fixture. This will be the fixture. So in the other tools, you'll fixture to it. Oh, that's very well. And then, of course, tool enabled means you can turn it on or off. And, of course, the execution time, this took 35 milliseconds to go out and find this Cognex logo. Under the Settings tab, you can set the number to find, the number of models to find. Threshold. If you're new to Vision View, every time you basically make an inspection, you look for something, it gives it a score. And how similar is this to the original? Threshold, you're setting the score in this case at 50. If the score when it looks at something is 50 or more, it would say, yes, this is what I'm looking for. If the score was less than 50, it would say, no, that's not what I'm looking for. That's something that you would set based on your lighting, your field of view, your part, etc. Rotation tolerance. Excuse me. One of the things that we said you're looking at with a fixture is the angle. It goes out to look for this model. How much tolerance for the angle do you want it to have? You could, in theory, put in 180 degrees. That means you could turn the part all the way around, and it would still find it. Again, the question is always, Not can it do it, but how fast you want it to do it. You really think your parts are going to come down the line 360 degrees or 180 degrees from where they were? If so, yes, set it. It will take a little extra time to look for those tolerances. If you think it's only going to be moving 5 to 10% angle, then set it for 15 and you won't have to worry about it. And it will do it much faster than if you'd set 180. Scale tolerance is basically the same, but in this case scale. Is every part or is every model on that part going to be relatively the same size? And generally you want to add something here. Zero tolerance is kind of dangerous. You're always going to have a little bit of a scale difference, even if it's a matter of taking the same picture or two pictures of the same thing. So you always want to have a little bit there. Scoring, I have an example of that coming up, so I'll put that off for now. Horizontal offset would be the part moving in the X direction. Vertical offset would be moving in the Y direction. In the result down there, you can see it's showing you the X coordinate, the Y coordinate, the angle, and the score. A little bit more detail there. You can see the models we talked about, the score, how much can it change. I think we talked about all this actually. We'll move on to the next one. Here is a little bit about strict scoring. This is always a little bit confusing for people, so let me walk you through this. If you look at the two pictures on your screen, the difference is that little bit of dirt right in the middle. So if you were looking at only the picture, only the wrappers on the left, without the piece of dirt in it, obviously the score is not going to change. It's not going to make any difference whether you check that box or you don't check that box, which is something people do. They check it, they don't check it, the score doesn't change, and they think, oh, something must be wrong here. Well, no, because nothing has changed. On the right, now you've added that extra little piece of dirt there. So if you turn on strict scoring, it will subtract from the total score for that dirt. Or unchecked, when it didn't take into account that little piece of dirt, was 99. When you check the strict scoring, it dropped down to an 87. And that depends on what you're inspecting, that depends on your environment. We also have added in EasyBuilder a palette with a results tab. And this is what we're showing you here. You can see that on the bottom, under the results tab, it says pattern _1. That is the model that you've set, the fixture you've set. And again, it's giving you a green light saying that it's and it's displaying the X, Y, and angle. The score, in this case, is cut off, but the score would also be listed there in the palette. So again, here, just a couple more examples of fixturing. The example I'm going to show you here in a second, we're going to use the Cognex logo as shown on the top. But you could also use edges, circles, or blobs. So let's have a look here. I'm going to switch you over now to EasyBuilder. Do you have EasyBuilder up on your screen now?
Yes.
Yeah, slowly, it's refreshing.
Okay, I'll give it just a second. Here, this again is EasyBuilder. This is brand new in version 4.1. You can see right in the middle there is the actual image from my camera here in my office. The spreadsheet, as I'll show you in a minute, if you come from the older versions of Insight, still exists. It's just in the background. This looks very much like Checker, if you've ever seen the Checker product line. Also looks very much like Intellect, which was the DVT product line. So basically, again, we've taken the best of both worlds and put them together. So along the left there is your application steps. Again, step by step, what you need to do to set up a job. In this case, you can see in orange that we're on the Get Connected. And when you're in the Get Connected step, down on the bottom, you can see here is all of the cameras and emulators here in our office in Duluth. One of them here. This one right here happens to be my camera. So we'll say connect. And here in the middle, now you can see under the sensor information, you can see we're connected to my camera. An Insight 5400 model, and I just put my name there so it's easier to find. It also connects to an emulator this way. An emulator, I know you said you were new. Emulator is basically a simulation so that you can test your job that you've created. Like in this case, you see the icon's a PC. So the emulator basically is my PC. So if I've created a job and I want to test it, test different tools, different functionality, I can actually just take a film strip, a picture from someone else's camera, put that on my PC, run Insight in an emulator mode, in a demo mode, and go ahead and inspect it. So that when I get ready to go live, I don't have to do all my testing live, have the line shut down. What's nice here versus the old versions of Insight, you click the emulator. In this case, this is my PC. Click emulator. I can go ahead and change the mode right here off the bat. That used to be about 10 steps in the old version. Okay, well, let's connect to my camera again. Here's my camera. Connect. I'm going to open an existing job, so I'll say open job. And on my camera right now, you can see there's only one job, demo job. Let me also point this out to you, since you said you're a little bit new, you're new to Vision View. What we're working with right now, all of the processing power within Insight is on the camera. The PC in this case is only the interface. The brains is all inside the camera, what we call a smart camera, as opposed to a remote head where the lens basically and the CCD run the information from it and run on a cable back to a processing unit. Or in some cases they run to the PC, and the PC is where the processing power is. With the Insight cameras, the brains, the processing power is inside the camera. So that job we're looking at there on your screen there, demo.job, is actually stored inside the camera, the flash memory. This particular camera has 32 megabytes of memory. So I'll just click on demo here and say open. And you can see now that we have a job open. So let's go ahead and I'll show you the next step. Excuse me. Set up image. Set up image down on the bottom here. You can acquire or load the image. Trigger means to go out and trigger my camera. So if I put my hand out here, you can see that this is me taking pictures with my camera here in my own. Live video is just that. Now it's active. It's going crazy on your screen, but I'm putting my hand underneath the camera so that you can set up your part for inspection. On the bottom it says load images from PC. Then I have stored on my PC here images that I've received from different customers. So I can go out and we'll find one here. So, for example, here is some images of a customer who they're using the camera to look for different flavors of ice cream. So this label, what they're doing with it is they use the hood in the top left there, which is the name of the company, as their fixture, and then they go out and they look for where it says peanut butter and chip trails. They have many different flavors of ice cream. So it goes out and makes sure that basically that if it is peanut butter and chip trails ice cream, it is in a container that says peanut butter and chips trails ice cream. A lot of people are, for in this case, allergic to peanut butter or to peanuts. So they have to make darn sure that anything that has peanuts in it is labeled that it has peanuts. Then there's a typical application. I'll go back here and I'll trigger my live camera here. There we go. In the middle here, this is information for the camera. You can control the type of trigger the exposure, the lights, if we have lights connected, etc. And on the bottom right here, this is calibration. Typically in vision systems like this, you have CCD. CCD has pixels in it. So when you measure something, all it knows is how many pixels across it is. You have two choices. You can do a scale calibration. If you have something in the field of view, then you know what the size of it is, or you can take a scale, a ruler or something, and put it in the field of view and measure it. Or you can use a test chart, what we call grid calibration. So I'll tell you what, just that you all are new to EasyBuilder, I'm going to start a new job, basically start from scratch. And I'll show you how easy it is to do a calibration with EasyBuilder. I'm going to call up scale calibration, and I'm going to use an edge-to-edge calibration. Select edges. Let me expand this picture for you. Can you see it's gone out and it's identified the edges for you, all the little blue lines. That's new in EasyBuilder. One of those edges, whether they're circles or straight lines, is called a feature. So this is called smart features. It goes ahead. You don't have to go out and look for an edge or a feature. It finds them for you. In this case, this is a picture of our new micro camera, which I know is 30 millimeters across. So I'll just click on two edges here. Boom, boom. Leave it millimeters. I'll tell it it's 30 millimeters. Calibrate. Done. Now everything we look at from this point on, it knows the scale of it based on what I just told it. Locate part, which is our subject at hand here today. You can see, as soon as I clicked on locate part, it shows you the available location tools, as we talked about before. PatMax, patterns, edge, blob, and circle. So I'm going to use PatMax. So click PatMax, say add. Here in the pink, this is your model region. This is where I'm going to tell it, this is my model, this is my fixture. And I'm going to set it around the Cognex logo here. And say OK. Done. You can see over on the right in the palette now, as you saw in the slide, it's generated a location tool called pattern_1. On the bottom, you can see the trained image, which is the model. That's actually what's in the memory of the camera to go out and look for. Here in the General tab, again, we could change the name. Let's change the name. We'll call it Locator. So now we can save that. Notice the name up here in the palette changed as well. Under Tool Fixture now, we have none because the next tool that we create, Locator, will be what we want to fixture to. Tool is enabled. It took 40 milliseconds to find this logo within the search region. This is the search region. In this case, I have the search region basically set for the entire field of view. Go out and look for the Cognex logo somewhere in the field of view. Settings, we went through these before. I won't go through all of them again. But you can set it. For example, for the rotational tolerance, I'm going to change that to 30 degrees. Put a little bit of scale tolerance in here, maybe 5%. Okay, so that's it. Now we're all set. Just as an example, I'm going to go in now to inspect parts, and I'm going to set an ID tool, just as an example. That is a class that will be coming up. For this case, I'm going to say read ID codes. Basically, I'm just going to tell it to go out and look at that 1D matrix there. Also put it around there and say OK. You can see here that it read it. It decoded it and found that it means ABC123, which it does. Now I'm ready to go live here. So I'm going to say Run Job. Results tab here. Let me move this in the X direction. You see how the part moved, but because of the location tool, ID tool moved as well. It saw that the Cognex logo moved in the X direction, so it took the ID tool and moved it the same amount, so it knew where to look for the ID code. Or this time I'll move it in the Y direction. Same thing. So you can see as I move the part around, because of the location, it knows where here. I'll turn the angle. It knows how many degrees, how far in the X and Y direction you've moved the part, and it's adapting to it. Well, that was a quick and dirty description of location tools. I hope that helped. Do either of you have any questions?
I had one back a little while back. You were talking about the rotation, and it takes longer and all that. Approximately how can you figure out how much longer it would take to do a 15-degree rotation versus, say, a 180? And I know there's, the more you look at, obviously, the more processing power it's going to take.
Trial and error, basically. There's no mathematical equation. There's too many variables at play. If it's a straight edge, it probably isn't going to be much of a difference. If it's a pattern, a very complicated pattern, for example, sometimes people use the entire part as a location. If it's a very complicated pattern and it's very large and you've set it for 180 degrees, that's going to make a significant, relatively speaking, difference in time. If it's just an edge, not going to make a big difference.
Okay.
Does that help?
Yeah. In the case I'm looking at, we print a code on the bottom of the ice cream container, and it could be oriented in any direction, and we need to make sure it's there.
How the code you're using, is it text? Is it a barcode? What kind of code is it?
Text.
Text. And how many different models, how many different versions of text are there?
It's pretty much the same code throughout the day, other than it does have the time and date in there, which increments every minute, of course. But other than that, the text itself doesn't change.
So that isn't that complicated. That shouldn't make a big difference. And that's perfect. That's what the ice cream folks, the example I was just showing you, that's exactly what they do. They come out, because it's packaging like that, it does rotate anywhere 360 degrees. In their case, it doesn't really move in the X and Y direction. It just is strictly a matter of the angle. Exactly. And it really, that shouldn't be a big difference. Reading text like that, or text as a model, is a fairly easy thing to do.
Okay, because we've got them coming by about 3 a second, so I've got 300 milliseconds, and then there's another pint there to be read.
Shouldn't be a problem. If you were looking for a picture, like you saw that picture of the ice cream I showed you, had a picture on the front of the ice cream. That was going to be your model. The picture, that was very time consuming. The text shouldn't make a big difference. Should be very easy to spot.
Okay.
Is it black text on white?
Yeah, the shades of white do change, and sometimes the darkness of the ink changes. Sometimes it's a little more faded out, but generally overall it's black on white.
Yeah, that should not be a problem.
Okay.
Do you have another question?
I'm good.
No, I think all things fairly explanatory.
Okay, I wish we had more time here. Stay tuned. What we're doing, we've started the live classes for EasyBuilder. We had the first one up in Detroit 2 weeks ago, and the next couple are going on. I'm doing one here in Duluth next week, and we have another one in Detroit. So if you're interested in coming to a live class, and schedule yourself for those. Meanwhile, if you can't get here, what we're doing is every Friday we're putting a different chapter up there. So over the course of the next month or so, basically we'll have the whole course up there for you to go and review at your leisure. Obviously it's not as being here live, where I can actually show you in one-on-one. So with that, unless you have something else, hopefully I'll see you here in the classroom someday.
Sounds good.
All right, thank you. Have a great weekend.
You too. Bye-bye.